Hello people, welcome back to my channel. So hope you are enjoying the Python skill series so far. So we are currently into the NumPy library. We are reviewing about different methods and different functionalities and different features and some of the codes and snippets so that we can broaden our knowledge in data science. So this is the fourth part of the NumPy series or the NumPy library discussion. So in today's video, we'll be seeing some of the matrix operations. So previous video was about the np.where, and before that we saw what was dimensions and matrices, different kinds of matrices that we saw in the numerical Python library. So in today's video, we'll be having a small use case or a business use case based upon the matrix operations, and so we'll be deriving certain insights from that. So again, for this we require a data set. So again, I'm taking a dummy data set. This is not a real one. This is created solely for the purpose of this explanation. So I have a data set that is called as Verkauf. Now Verkauf is a German word which is basically for sales. So this is my data set, and let's have a quick overview of what are the different columns are there. So first, what you can see, that is the store number, and then you have the city. So for city, I have considered three distinct values. So I have Thuringia, then I have Schleswig-Holstein, and then I have Saxony-Anhalt. So basically, these are not city; these are different states in Germany. But I've put a city column, so let it be as it is. And then you have the different uh, months. That is the 12 months across the year. So from Jan to December, and then what you can see uh, for each of the columns, you can see the total number of sales that are there. So before this data set, what I've did is I've did a small pre-processing. So this basically sales are in you can see like this numbers, what you can see that I've considered as real numbers. So originally it was something like 8.00. So you have this number system in Germany, like if you have a value 8.000, this stands for 8000, where in other number systems, if you had something like this with comma, that represents 8000. So here we have point triple zero to all of these values. So for simplicity, what I've done is I've considered only just the real number so that our calculations, our understanding becomes easier. So this entire data set has two columns which are just the categorical columns, and all other columns, that is 12 columns which are there for each of the months, those contain all real value. So our focus will be on that particular columns. So this was a small overview of the data set that we are going to use. So I have already imported this dataset onto my workspace. So we'll do some certain matrix operations. So for this, first I'll be requiring this dataset onto my workspace. So I just import this, and I can see this is my uh, dataset that I have, and it will do the automatic indexing. That is, you have 0 to 99, that is we have 100 rows and 14 columns. Now for analysis purpose, what we need to keep in mind is that we don't want this particular uh, first column and the second column for our calculations. Just we require only the 12 months of the year. So from Jan to December, we just require these numbers for our calculation. Now for that, let's understand what is our business requirement is. So our requirement is to compute the month wise growth in sales of that particular store. So across this particular cities, you can see there are different stores. Like stores are given by the store numbers as 100 up till you have uh, S199. So you have these many entries, that is 100 rows. So we want to calculate certain kind of month-wise growth in sales. How much growth has happened every month? Was there a decline or was there an increase? So for that, we'll be basically doing some kind of operations that will be based on the NP NumPy libraries. So for that, we require the NumPy library. So I'm importing the NumPy library as NP. So our step one will be to import the NumPy array. So whatever values we can see in this column, we want to convert into array. So we have seen what was the array and what are its capabilities and features that we can do. So what I'm doing is, first of all, I don't want this store number and city for my calculation. Why? Because those contain categorical values. So for that, I'm basically using the LOC function. So we have already seen in pandas, that is in data frames, how we can get rid of this. That is, I'm using the label based indexing. So I will just mention the column that I want. So I want all the rows, that is indicated by this, and from Jan I want till the end, that is till December. So that gives my particular sales matrix, what I call here. And here what I'm printing is, I'm printing the sales matrix, and I'm doing a matrix shape. So that is the original shape of the matrix, how it is there after performing the LOC or the slicing. So that will later understand when we move on to the program below. So when I run this, you can see this is how my uh, NumPy array looks basically. And this, what you can see in tuple, this is nothing but the resultant of this particular code, that is matrix.shape. So it is like 100 rows and 12 columns. So that makes a total of 1200 entries. So that is the size of the matrix which you have. This is the shape, and size is, you just multiply this, that is 100 into 12, you get 1200, 1200. So this was our step one, that is kind of selection, label based selection. You can also go with the positional selection. So there you will mention ilog, and for that you require the numbers but not this string. So basically you will write one or two, whatever is the particular index of that column is, so from where it starts, so you need to mention that. So now after we do this, our steps 2 consist of a particular expression. So for that I'm introducing a usage of C underscore expression. So let us understand what is that. So np.c is particularly not a method, but it behaves something like the df.loc. So similarly, how you have used the df.loc or df.iloc, those were not methods, but it is basically a selection operation, or for doing some kind of slicing of stuffs like that. So similarly, np numpy consists of c underscore expression. So what it does is, it basically takes two arrays. So here I'm passing a list, that is 1 2 3 to np.array, and the second value that I'm passing is, that is also an array, and to that I'm passing 4 5 6. And if I run this, what I observe is array, something which is arranged in this fashion. So what does this basically? So how is this doing the computation? So it is basically concatenating. So this can be understood as a concatenation. So concatenation on the second axis. Second axis means horizontally. So what it does is, the first value of the first array and the first value of the second array, it will just club them together. So it is represented in this way. The second value of the first array and the second value of the second array, it will club in this way. Third value of the first array and third value of the second array, it will club in this way. So now you might be thinking why this is basically used. So this is mainly used for doing certain kind of calculations, like when you do any singular value decomposition. So there, in intermediate steps, you may require to compute the transpose or something like that, or in covariance matrix or stuffs like that, you basically need to do the data transformation in between. So for simplicity, we do this kind of expressions, or write this kind of C underscore expression. So it basically concatenates. So as a resultant, you get a concatenated array. And so this is how it basically works. So it is not a function, but it works like the log and ilog of the data frames. And where it is mainly used for regression analysis, and especially it is used as a bias. So whenever you input into the regression analysis the bias constant that you add, that is y is equal to mx plus c. So there at the C place, you mainly pass this kind of matrix that we'll be seeing whenever we do the linear regression video. And also it is used for pipelining and processing, that is pre-processing. So these are the places where this kind of expressions are typically used. Now we'll understand what is the role of this C underscore expression in this particular use case. And there is one more representation to this. So you might think like this is exactly the same, but this is not exactly the same. Here you have a to list, so that is, you can consider as array of list. You are converting into an array, but you have two list inside this, or you can consider this as one array, and in that array you have one list, or two arrays basically. And then you have some values. So the output of this is you get something like this 1 2 3, and you have two zeros 4 5 6. So this is one representation, and this is another representation that you get. And if you want more information, you can visit this particular site. So this is from Stack Overflow, so where you have tons of questions answered from prominent people who are working in this area. So here are some discussions on this particular uh, np underscore c function. So you can read this later. So if you didn't understood from my discussion, you can just go through this particular site. So let's get back to our discussion. So what we now want to do is, in our step 2, uh, we want to do a slicing operation. Now why slicing? Because we have did a slicing here. So this is nothing but we do a slicing operation. Now why need to slice the operation or slice the matrix that we already have? So that is done in order to take the matrix difference. So like when you calculate the growth or sales per month, what you do is you just eliminate one column, and then you just do the further computations on the remaining part of the data. So that is one kind of business logic that is followed in organizations. So when you do more practice on these data sets, you will get an idea of how these things are basically done. So like a simple example is like when you calculate the simple interest or compound interest, you have different values p and rt divided by 100. So similar stuff is followed in that, but here since you are dealing with the matrices, you have to do certain kind of things here. So first what we did is we are extracting only the numerical columns, and after that we are doing a slicing. So the resultant of this what we get is, so if I just print this particular thing, so what you can see is it starts from 2019, 16 and so on. And here we have 8, 12, 16. So what it basically did is it just omitted this entire first column, and it started from here. And here the shape was 100 comma 12. Here we get as 100 comma 11. So now we want to compensate this particular uh, dimension reduction that we have obtained. Now here if you observe, since we have did a slicing here, we are one column less, so we don't have our January column entry here. So for that, basically what we do is we run this np dot c underscore expression. So into that we are passing this matrix, sliced matrix, and to this we are passing something we have already seen or familiar, that is np.zeros, and to zeros we are creating a matrix which consists of 100 number of zeros. So if you remember that particular video where we saw or introduced regarding the np.zeros, it created a matrix with all zeros, but those zeros were all in floating points. So what this basically does is, when I run this, you can see this particular dimension. Now it is 100 comma 12. So now this becomes easier for our further computation. And so since we have did one slicing here, it will compensate by adding this zeros. So further, whenever we want to do the analysis on particular month, and if we remove that by this slicing, then the np.zeros will compensate so that it maintains the dimensionality. So there the dimensionality is not lost. So since we have sliced one, so that will be filled with zeros there. So np.zeros basically helps there, and so it has this representation because of this discussion that we did here. Then after the step 2, what we do is we just check the size of this. So both the matrix, that is the sliced one from the above, this part, it is 1200, and the original matrix that we have, that is also 1200. So we have these two things. Now what we want to do is we want to do the subtraction of two matrices. So what we basically obtain is the sales difference. So for doing the matrix subtraction, uh, dimensions of both the matrices should be same. So for that we calculate the sales difference, and in sales difference we have the sales matrix, that is the modified one from the step 2, and from the step 1 we have the sales matrix. So this can be realized like whenever you do certain kind of percentage calculations. Like how you calculate percentages is like you take the obtained score at the numerator, and to the denominator you take the total count or total marks, and then you just multiply with 100. So similar logic is followed here. So and if I print this particular, you get in this way. So what it basically did is it did the subtraction. So this particular matrix minus this one. So just for checking, 20 minus 8, you obtain it as 12. 13 minus 20, you get as minus 7, and all values are in floating point. And also the dimension remains intact. Now what we want to do is we just want to calculate the percentage. So how we calculate the percentage is like, uh, I previously mentioned, like the sales difference what we have here, that is this value divided by the sales matrix, that is this one from the step 1, and this I'm passing to a data frame. So the resultant that I want after this step is a data frame. So I want to populate in a data frame where I have this values. So sales difference divided by the sales matrix. So whatever value or in decimal point it has, it will be our percentage difference. Now to this percentage difference, I am multiplying this 100 so that it will be in percentage format. So that becomes easier for our understanding. And now I am doing the head. So if I look into the final result for our month-wise growth sales per year, so if I see that is the first zero, this represents January, February, March, April, May, June, July, August, September, October, November and December. So 0 to 11, you have 12 columns representing the 12 months of the year, and you have this particular data. So what it basically reveals, and so what will you show your customer? So how would you explain this particular data? So you can see there are some positive values and there are some negative values, and you can see there are some values like if it is minus 35.000, and for all others you have same kind of representation. So that is basically used for the granularity, like the Python does internally. So the NumPy calculations does internally. So it basically might have computed this as the first value, and so the second value also it will keep up to this granularity so that it becomes for all values to be compared in one scale. So whatever values you can see in positive, so that is a positive sales growth in that particular month, and whatever negative values you see, like towards the negative number scale, the sales went down. So there was a decrease in sales in that particular month of that particular column. So this is how you do the small analysis based upon the monthly sales of a particular store or in a particular city. So well, that was all regarding small introduction of the matrix calculations and operations, and also the usage of C underscore expression, which is used in data science, also for many other further calculations that we'll be doing. So hope you guys enjoyed this video. If you found you got edge watching this video, please do like, share, comment, and if you are new to this channel, please consider to subscribing. Thank you very much for watching this video.